Hey, so this is the video on implicit differentiation by Ben and Jeremiah. So we're going to start off with a very simple example. Y squared equals x. So in implicit differentiation, we're trying to find what dy dx equals. So first, let's start off by taking the derivative. So the derivative of y squared, the exponent comes down, is 2y dy dx. And we also have to take the derivative of x, which is 1. So now we have to solve for dy dx, meaning we have to get it on its own. So what we're going to do is we're going to move 2y over to the other side. So in order to do that, we have to divide both sides by 2y. So we get dy over dx equals 2y. 1 over 2y. Okay, our second example is a little bit more complicated. It's x squared times y plus y squared equals 6. And we're still trying to find dy dx, right? That's the point of implicit differentiation. So first, we're going to take the derivative of all terms, right? So we're going to have to use the chain rule. So it's going to be the first times the derivative of the second plus the second times the derivative of the first. That's chain rule.
Product rule.
I mean product rule.
Cool.
We're going to use product rule. Okay, cool. So first times derivative of the second. So I'm going to put a little parentheses here. So x squared, the first times the derivative of the second, which is 1 dy dx. I'm not going to write the 1. Plus the second times the derivative of the first. So the derivative of the first will be 2x and the second, which is y. Close parentheses. Next term is xy squared. So first times the derivative of the second, so x times 2y, but I'm going to bring the 2 out here. So 2x y dy dx. And then the second times the derivative of the first. So derivative of the first would be 1, so derivative of x is 1. And then 2y, no, I'm sorry, y squared equals the derivative of 6 is 0 since it's constant. Here we go. So I'm going to bring these all out of parentheses. X squared dy dx plus 2xy plus 2xy dy dx plus y squared equals 0. So what we want to do is we want to get dy dx on its own on one side. So first we're going to move all the terms that don't have dy dx over to the other side. So we're going to leave x squared dy dx. We're going to subtract 2xy and y squared from this side and move it to this side. So we're left with x squared dy dx plus 2xy dy dx on this side equals negative 2xy minus y squared. And so we're still trying to get dy dx on its own, right? So we're going to factor out a dy dx out of this side. So we're going to be left with dy dx x squared plus 2xy on that side. And we could factor out an x, but the point is to get dy dx on this side on its own, so that would just add another step that we'd have to undo. So I'm going to leave that in here, equals negative 2xy minus y squared. I'm going to factor out a negative 1 out of this side, so I'm going to make these positive and just put a negative on the outside, because that'll make this next step easier. So I'm going to divide both sides by x squared plus 2xy to get dy dx on its own. So dy dx equals negative 2xy plus y squared over 2xy plus x squared. And so that is our answer. That is dy dx. And that is implicit differentiation. Thanks for watching.